Compression for IPTV. In order to produce IPTV with today's technology, video programs need to be compressed. A 2-hour uncompressed standard definition television program produces 97.2 gigabits per hour, while an HD TV, which is high definition television, produces 5,300 gigabits per hour. And the storage requirements for a standard definition television 2-hour standard definition television program is 200 gigabits. A DVD-ROM only holds 4.7 gigabits. This would only account for a few minutes of video. Finally, the bandwidth requirements for an uncompressed signal need to be capable of handling 216 megabits per second, while DSL and cable only handle a few megabits per second. Ethernet for LANs runs only between 10 and 100 megabits per second, although they do have gigabit Ethernet, but it's not in wide use. So in this video, I'll talk about the different compression technologies now and what the future will bring. MPEG-1 was built for CD-ROM applications and is designed for up to 1.5 megabits per second. It is a popular standard for video on the internet and is the most popular standard for MP3 audio compression. MPEG-2 is built on MPEG-1, but is designed for compression and transmission of digital broadcast television. The big difference between MPEG-1 and MPEG-2 is 2's ability to efficiently compress interlaced video, and it works well for HD TV. MPEG-2 is designed for up to 15 megabits per second. MPEG-1 and MPEG-2 are widely used today. When we talk about MPEG-4, we're looking at the future because it's not in wide use yet. MPEG-4 uses object-based compression, where individual objects are tracked separately and compressed together, resulting in a very efficient compression scheme that is very scalable, with a range from very low bit rates to very high bit rates. And it also introduces interactivity. This chart shows the different bit rates needed to transmit quality video. The top bar is uncompressed digital video at 4 by 4 by 4. The next bar down is uncompressed 4 by 2 by 0 color sampling. The third bar from the top is motion JPEG. The fourth is DV25. Next is MPEG-2, and finally MPEG-4. MPEG-4 only requires around 3 megabits per second, while the top bar is almost at 400 megabits per second. The acronym MPEG stands for Motion Pictures Expert Group, and JPEG stands for Joint Photographic Experts Group. JPEG is a lossy compression standard that works by exploiting the fact that the human eye will not notice small color changes. JPEG 2000 will use compression techniques based on wavelet technology. MPEG-7 is still under development. This standard should provide a framework for multimedia content with information on content manipulation, filtering, and personalization, as well as integrity and security. Finally, there's MPEG-21. Work on this standard has just begun. MPEG-21 will attempt to describe the elements needed to build an infrastructure for the delivery and consumption of multimedia content, and how they will relate to each other. In the beginning of this presentation, I talked about the reasons for compression in conjunction with IPTV. Then I briefly described the various compression technologies, such as MPEG-1, MPEG-2, MPEG-4, JPEG, and JPEG. Finally, I talked about the compression technologies of the future, such as MPEG-7 and MPEG-21. And that concludes this presentation.